Welcome my dear learners for this course on engineering graphics. In this module 2 we were discussing on orthographic projection of plane surfaces. So far we have solved 4 problems on orthographic projection of plane surfaces. Moving ahead, the problem number 5 of our discussion states that a triangular laminae of 25 mm side rests on one of its corners on VP such that the median passing through the corner on which it rests is inclined at 30 degrees to HP and 45 degrees to VP. Draw its projection. Here the triangular laminae is resting on one of its corners on HP. It is resting on HP on one of its corners. So far what we have solved, the 4 problems. Of all the 4 problems we have solved such that the triangular laminae is resting on HP. For the first time we are encountering a problem on which the triangular laminae is resting on VP on one of its corners. So since the laminae is resting on VP on one of its corners, in the front view I will get the equilateral triangle and in the top view I will get the straight line of this triangular laminae. As we are using 3 position method, in the first position let me don't show the inclination to any of the planes, just I will place the triangular laminae on vertical plane. In the front view I will get the true dimension of the laminae. And one more thing is that we are using left hand reference. That means if it rests on edge, I will take edge towards left in the first position. If it rests on corner, I will take corner towards left in the first position. Here it is resting on one of its corners. So therefore let me draw the first position of the given problem in which the laminae is resting on VP and it is an equilateral triangle of sides 25 mm. Now let us solve such a way that I will get corner towards left. So the laminae is 25 mm. So draw the laminae which is 25 mm. Having all sides equal 25 mm means it is an equilateral triangle. I will draw such a way that I will get corner towards my left hand side. So now measure this 25 mm, cut 2 arcs. Done. Now connecting which I will get the required triangular laminae. Now I will call this as A, B and C. So since it is the front view, I will call it as A dash, B dash, C dash. Let us call this as VP, HP, X and Y. This is a solution for problem number 5 what we are discussing. Now take the projection. So take the projection. So here I will get the required laminae. This is A. In the top view C is visible, B is invisible. So it is C and B. Done. Now such that the median passing through the corner. So I want the median. So median will bisect this side at 12.5, 12.5 each. So draw the median. So median is drawn. I call this as median as A dash, M dash. Now this median makes an angle of 30 degree to HP and 45 degrees to VP. Now as I already explained so far, if the laminae rests on HP, in the second position we must show inclination with respect to HP itself. If laminae rests on VP, we should show inclination with respect to VP itself in the second position. Here the laminae is resting on VP. In the second position I should show inclination with respect to VP itself. So inclination with respect to VP will be shown on HP. So it is inclined to VP at 45 degrees. Show this inclination to VP at 45 degrees on horizontal plane. So therefore mark a reference point. So it is resting on one of its corner on HP. So on VP. So this will become A. So measure 45 degrees. So measure 45 degrees. We should show inclination with respect to VP itself because in the first position it is resting on VP. So shown 45 degrees marked. Now measuring this median, so median is coming 22 mm. So mark this 22 mm at an angle of 45 degrees. At an angle of 45 degrees, mark median of 22 mm. Mark the median of 22 mm. So this is M. So AM I have marked. Now A dash M dash. So this itself is M dash, M, right? So if I look at from top, this is C dash, B dash and also M dash. So since M dash is an imaginary point for median what we have taken, the entire lamina will be inclined at an angle of 45 degrees. So this itself is inclined angle of 45 degrees. So this is nothing but C and B and also in brackets M. No need to worry. So this is inclined at an angle of 45 degrees. The lamina itself is representing the median A dash M dash. You can see here lamina itself is measuring A dash M dash. So that is what we have marked here. So this length I have measured, picked it, placed it and rotated to an angle of 45 degrees. Done. Now take the projection and complete the sketch. So taking the projection, I will get, so A is here. So take the projection and mark points C dash and B dash and also A dash, and here I want A dash M dash. So thereby I got A dash, B dash, C dash, M dash. Now join A, B, C to get the required lamina. So joined A, B, C. So A dash, B dash, C dash. Now the careful observation will reveal that here the median dimension is more, here the median dimension is less. Now I want to incline the median which is passing through the resting corner at an angle of 30 degree to HP. So now I should incline this median at an angle of 30 degrees to HP. Now to do that I want apparent inclination, because the 30 degrees what he has given is for the true median A dash M1 dash, but what I have A dash M dash is of apparent dimension when compared to A dash M1 dash. So therefore I should go for apparent inclination. Apparent inclination with respect to HP is called as alpha. So this is an alpha angle problem, because we are showing apparent inclination with respect to HP which is shown on VP. Whereas in our previous problem number 4, we have solved a problem on beta angle, wherein which we have determined the apparent inclination with respect to VP, which I shown on HP. Here I want apparent inclination with respect to HP, which I will show on VP. Repeating the same procedure on vertical plane, I can extract how much is the alpha angle, that is the apparent inclination of this median. So for which first you lay down the true inclination. True inclination is 30 degrees. So mark 30 degrees. So draw the true inclination of 30 degrees given in the question. Mark 30 degrees. Draw a line. Draw a line of arbitrary length at an angle of 30 degrees drawn. On this 30 degree line I want median to be placed. Right. Now measure the true length of the median. So true length of the median is measuring 22 mm. So measure 22 mm on this. Let me fix point A dash and measure 22 mm on this. Measure 22 mm and call it as M1 dash. I will use different chalk for true dimension. So I will mark it as M1 dash. This one I placed it here. Now fix the locus. I will keep A dash. I will fix A dash. I will float M dash. So therefore fix the locus of M dash. So draw the locus of M dash. So we found locus of M dash. Now using compass, you measure the apparent length A dash M dash. Keeping at A dash, you intersect the locus. Now we got actual M. That is, I should use actual white chalk. So this is M dash we got. Now passing through this M dash, A dash, you connect to the XY line. And now you measure how much is the alpha angle. How much is this inclination? You show it as alpha, apparent inclination of the median with respect to HP. So if I measure, it is measuring 44 degrees. So we found alpha angle. Now using A dash M dash, you complete the sketch. So A dash M dash is perpendicular bisector for B dash C dash. So therefore draw 12.5 offset at M to A dash M dash. You draw perpendicular line of 12.5 on either side. 12.5 on either side and connect. So this completes the required problem C dash B dash. So this completes the required problem. Now find out the final position. So to get the final position, just you take vertical and horizontal projections. And extend the sketch C dash to C and B. So it should go till end. And here itself I will get A. So this is A, this is C, this is B. So final top view is this one, A, B, C. So I got the final top view. So this is the solution for problem number 5. Problem number 4 and problem number 5 are almost similar, wherein which problem number 4 deals with beta angle, problem number 5 deals with alpha angle. Now moving ahead, the problem number 6. Let us discuss the solution of problem number 6, which states that an isosceles triangular plate of negligible thickness has base 25 mm long and altitude 35 mm. It is so placed on HP such that in the front view it is seen as an equilateral triangle of 25 mm sides, with the side that is parallel to VP is inclined at 45 degrees to HP. Draw its top and front views. Also determine the inclination of the plate with the reference plane. Now if you carefully observe, we have an isosceles triangular plate placed on HP such that in the front view it can be seen as an equilateral triangle of 25 mm sides. Don't get confused. Even though it states it is placed on HP, it is not lying on HP or resting on HP. It is placed on HP like this, because in the front view I want the triangle. In the front view I want the triangle, not in the top view. That is what he says. In the front view it is seen as an equilateral triangle. So triangle should be seen in the front view. So therefore, if this is the horizontal plane, the lamina is not placed like this, it is placed like this. The lamina is resting on HP like this. It is not lying, it is resting like this. So if it rests like this, then only I can see the triangle in the front view. So therefore, draw the isosceles triangle in the front view, for which I will draw XY line first and draw the isosceles triangle for the given dimension. Let me draw the XY line first. So drawn, mark VP HP. Now I want isosceles triangle of base 25 mm long. It is resting on HP with isosceles triangle of base 25 mm long. 25 mm long. So here also you mark, show the equilateral triangle side length at least on one side, which is 25. So this is given as 25. This is given as 25 and altitude is specified as 35. So take the perpendicular bisector and mark the altitude first. Altitude is 35. So mark the altitude. So taken the altitude. Now once I marked altitude, just connect. So I got the isosceles triangle. So this altitude is specified as 35 millimeters. 35 millimeters. I'll call this as A, B and C. Now if you take the projection, you'll get like this. So taking the projection, I'll get this as C, this as A, B is invisible, this is front view A dash, B dash, C dash. Done. Now here I'll get an equilateral triangle. I should get an equilateral triangle in the front view. So now what is the side length? It is placed on as such that in the front view it is seen as an equilateral triangle of 25 mm sides. So take the same length, that is 25 mm, and construct the equilateral triangle 25 mm. Now using compass we can construct the equilateral triangle. From top also if I intersect, I will get the equilateral triangle in the front view. I got the equilateral triangle in the front view. So this is A dash, B dash, C dash. To get this equilateral triangle, to what angle I have inclined this lamina is the question. So to find out that, so just take the projection from C dash and extend it. Now using compass, you measure this one A to C, which is 35 mm. So keeping it AB, you cut this. Now you join. So now if I join, I'll get to what angle if I tilt the isosceles triangle inclined to VP, I'll get the equilateral triangle in the front view. So find out this. This is what he has asked. Find the inclination with reference plane. So this is A, B is visible, this is C. Clear? So this extension you erase. Don't show this extension because lamina is just A to C or B to C. Now how much is the inclination that he has asked for us? So the lamina is inclined at an angle of exactly 50 degrees. So I am getting exactly 50 degrees as the answer. Now moving, at last we should show inclination with respect to HP. So what is the last thing he is stating? It is so placed on HP such that in the front view it is seen as an equilateral triangle of 25 mm sides. Done. With the side that is parallel to VP is inclined at 45 degrees to HP. So which side is parallel to vertical plane? Among these three we have A dash, B dash, B dash, C dash, C dash, A dash. Among these three sides, which side is parallel to vertical plane? So this is the vertical plane, and to this vertical plane B dash, C dash is parallel. Correct? So therefore incline this B dash, C dash to an angle of 45 degrees. So I will take this and I will incline it. So always we are rotating counterclockwise. So let me rotate counterclockwise and incline it at an angle of 45 degrees. So mark 45 degrees first. Mark 45 degrees first. Marked. So marked 45 degrees. Take a reference line. On this 45 degree line, place A dash, B dash. Place A dash, B dash. A dash, B dash is retaining its original dimension of 25. So mark 25, which is an equilateral triangle. So mark it. So I'll get B dash, A dash. Now using compass, you finish it. So locate C dash, locate C dash, and if I join, I will get the required final position. C dash. Now taking the extension, complete the problem. So B is only till here and A is only till here. So this will be A, this is B, and this is C, and this is C. Now connect A, B, C. An isosceles triangle plate of negligible thickness has base 25 mm long and altitude 35 mm. It is so placed on HP such that in the front view it is seen as an equilateral triangle of 25 mm sides, with the side that is parallel to VP is inclined at 45 degrees to HP. So this is how we should solve. So this is the solution for problem number 5 and 6. That's all from this lecture. Thank you all.